In another video, we mentioned redundancy among switches. In that video, I had actually put 2 lines from every switch to every other switch. But in this case, we've got 2 lines on this one and a single line here, but we still have a lot of redundancy. If this switch needs to talk to this one up here, switch 3 needs to talk to switch 1, it can go either this way through switch 2, or it can go directly to switch 1. However, I did mention that there is a problem here. Let's see what that problem is. Let's say that switch 1 is connected to a device that it is just now learning. In other words, that device is now sent out a frame, and we said earlier that when a switch receives a frame from a device that it's unfamiliar with, it looks at the source address and learns that source MAC address and puts it in its CAM table. And then after that, it sends that frame out through every other port except the one on which it came in. So let's say that this switch 1 has just received such a frame, and so it doesn't know where the device is that it wants to talk to. So it sends that frame out this way to switch 3, and it sends it out this way to switch 2. Meanwhile, these 2 don't know where it is, so 2 sends it out to 3. Well, now 3 has it twice. 2 also sends it back out to 1. 3 over here in the meantime sends it back up to 1, sends it out to 2. You can see what we have is pretty soon a loop going around, and we have a broadcast storm. These storms can bring a network down very, very quickly. So we don't want this redundancy unless we need it. We don't want 2 different ways to do something except when one goes down. So we use something called Spanning Tree Protocol, or STP. This is STP right here. What happens is these 3 switches elect a root bridge. And it's elected, by the way, based on its MAC address, the lowest MAC address, which usually means, by the way, that the oldest switch ends up being the root bridge, but that's another problem altogether. We can change that in a managed switch and make our newer switches the root bridge if we want to. Once we have a root bridge, every other switch decides which port is going to be the root port. So here's switch 3, the root port is the blue one here. So switch 3 has chosen this as the root port, and switch 2 has chosen this FA01 as the root port. So that is the one that is normally going to send that information over. It's only going to send it through the root port. And this one over here is blocked. So the blocked port, which is a non-designated port, a blocked port is a non-designated port, so it will not flood the information out through there. So we only have a one-way traffic, or not one-way traffic, but we only have one direction that switch 3 will flood information. Over here, we have blocked this port so that information will only flow up here from switch 2 to switch 1. It will not go from switch 2 to switch 3 because one of the ports is blocked there. So after each root port is chosen for each switch, then designated ports are chosen. Designated ports are the ones on which it can receive information. So all of the ports here on the root bridge are designated ports. And over here we have a designated port on switch 2, but nothing's going to come in on that at this point because it's blocked over here at switch 3. So even though this is a little bit complex, and by the way, it can get very complex figuring out all of these things, but effectively what we have done is allowed only one way to get information around unless that goes down. And at that point, it will open up a different path, a different route, so that the redundancy only occurs or is only used when when another line goes down. And that's Spanning Tree Protocol, or STP. You do not have to learn how STP works for purposes of the Microsoft MTA exam. You'll only have to know what it basically does. The fact that it blocks redundancy and blocks loops that occur as a result of redundancy between these.